In the silent vastness of our galaxy, a tiny object hurtles through space, flickering with an enigma that challenges everything we think we know about the universe. 3I/Atlas isn't just another speck of cosmic debris. It's a mysterious visitor, whispering secrets about the birth of stars, the restless dance of planets, and the fine line between the known and the unknown. As this distant traveler cuts through starlight and influences the fabric of space itself, it prompts a profound question. Could these wandering objects hold the key to understanding our place in the infinite expanse, or even hint at distant civilizations watching from the shadows? Stay with me, because what makes 3I/Atlas so captivating isn't just its trajectory. It's the universe's greatest puzzle, begging us to look deeper, think bigger, and wonder what's really out there. Genesis of interstellar visitors, a new frontier in astronomy. The universe's vastness holds secrets that continue to ignite human curiosity, and the origin of interstellar objects like 3I/Atlas pushes this intrigue to breathtaking heights. These wandering travelers, celestial bodies that neither orbit our sun nor belong to our solar system, arise from distant star systems, perhaps ejected during planetary formation or tumultuous gravitational interactions. Their journeys, often spanning millions of years through the cold interstellar void, are laced with cosmic drama, as they cross the boundary of our solar neighborhood, carrying clues about the environment, material composition, and dynamic processes of alien worlds. The very nature of their voyage hints at planetary chaos, star system evolution, and the transient chaos of cosmic ecosystems. What makes these interstellar visitors so mesmerizing is their capability to dramatically transform our understanding of planetary birth and destruction. They are witnesses to star formation, planetary collisions, and astrophysical upheaval, harbingers of cosmic change. When such bodies are detected, astronomers are greeted with a burst of light and heat, revealing their composition through spectroscopic analysis. Often, these objects are rocky or icy, sometimes bearing unusual features impossible to reconcile with our solar system's standard models. They remind us that planetary systems are not static. They are dynamic, often violent, and capable of ejecting fragments that drift forever into the dark, cold vacuum of space. The composition, including organic molecules and minerals, hints at the chemical diversity fostered across the galaxy. Ingredients for life, perhaps, amid the debris. The emergence of interstellar objects as an active field of study represents a breakthrough in observational astronomy. New telescopes, with astonishing sensitivity and speed, have awakened to the fleeting nature of these visitors. They appear suddenly, like cosmic fireworks, and vanish just as quickly, leaving behind lingering questions. For example, 1I/Oumuamua drew attention not only because of its unusual shape and acceleration, but also because it defied easy classification, raising speculations about artificial origin or unknown natural processes. Then came 2I/Borisov, a comet-rich body clearly originating from another star system, confirming that these visitors are diverse in morphology and behavior, further broadening horizons. Such discoveries challenge long-held assumptions about the boundaries of our solar system, hinting that it is merely a small island amidst a vast archipelago of planetary systems teeming with similar fragments. What lingers in the human mind is the profound existential question: are we alone in this cosmic wilderness? These interstellar objects serve as messengers, whispering stories of distant worlds and their violent, creative cycles. They remind us that the universe is a theater of continual transformation, where planetary fragments wander inertly or surge through space, carrying the potential to seed life or ignite discoveries that change everything we know. As we watch these cosmic wayfarers radiant with light and heat, we confront the vast, uncharted territories of existence itself, begging us to ponder whether our solitary planet is but a fleeting spark amidst a universe buzzing with the restless activity of eons. The enigma of 1I/Oumuamua, the Trailblazer's puzzle. In the vast darkness between stars, 1I/Oumuamua distinguished itself not by its size, orbits, but by its silent, perplexing presence. Traveling at an unprecedented speed for an interstellar object, It seemed to dart through our solar system with a sudden acceleration that defied conventional explanations. Its elongated, cigar-like shape sparked curiosity, yet it was the peculiar absence of a visible coma or tail that truly set it apart. Unlike typical comets, which release gas and dust as they approach the sun, Oumuamua appeared to be a mostly inert, rocky body with a mysterious force nudging it forward, pushing the boundaries of what was physically expected. This object shone with a subtle, uneven brightness, suggesting a rugged, elongated shape or perhaps a flat, pancake-like form. Some interpretations pushed the limits of imagination. Despite multiple observations, astronomers struggled to decipher its origin or composition. Was it merely a fragment of a destroyed exoplanet, a relic from another star system, or something more exotic? Theories ranged wildly, from natural origins like a captured asteroid, to the more speculative notion that it was an artifact of an alien civilization, possibly a piece of an alien probe or technology designed to explore. These questions linger like shadows, refusing to be neatly resolved, as Oumuamua vanished beyond the reach of our telescopes, leaving behind a trail of cosmic questions. Its unexpected acceleration, small but measurable, stages a silent battle against gravity's pull and the subtle pressure of solar radiation. This tiny yet significant push suggests that there might be forces at play beyond our current understanding. Perhaps light itself becomes a kind of unseen hand, influencing objects in ways we are only beginning to grasp. The behavior challenges existing models of small bodies, hinting at unexpected compositions or even hints of spacecraft-like qualities, though evidence remains elusive. Whispers of extraterrestrial engineering swirl around, yet no conclusive proof ever emerged. Only the persistent allure of the unknown. It hints at a universe far more dynamic, where even tiny objects hold secrets capable of reshaping our view of reality. In a larger context, Oumuamua ignited debates not just about the nature of interstellar objects, but about our place within a universe that seems to be constantly whispering, just out of reach. It confronts us with profound questions. Are we alone in deciphering the silent cosmic signals? Could these tiny travelers be messengers, or merely cosmic debris? It's a reminder that the universe, in its grand scale and tumultuous energy, continues to challenge human understanding, urging us to peer deeper into the abyss of space and thought. As Oumuamua slipped away beyond our grasp, it left behind a lingering reflection, an echo of curiosity that prompts us to ask, what truly lies beyond the stars we see, and what might be watching us in return? Emergence of 2I/Borisov, a commoditized interstellar comet. In the vast silence of space, an interstellar visitor streaked through our solar system with startling familiarity, revealing characteristics reminiscent of the countless comets born within our own celestial neighborhood. 2I/Borisov's appearance was unlike anything previously observed from interstellar objects. Its bright, diffuse coma and tail betrayed an active nucleus, shedding dust and gas as it felt the sun's warmth. Its trajectory suggested an origin beyond the familiar realm of our solar system, prompting astronomers to scrutinize this wandering visitor with awe. The discovery marked a shift in how interstellar objects are perceived, no longer distant anomalies but objects that seem almost commoditized, as if they have been encountered countless times before, even though each bore the imprint of a completely alien environment. What made Borisov so startling from the outset was its apparent compliance with the familiar behaviors of solar system comets. Its brightness fluctuated in a way that indicated sublimation, ice turning directly into gas, mirroring the volatile activity of comets long observed in our own backyard. Yet, beneath this outward similarity lay a mysterious origin story. The dust and gas released during its pass through the inner solar system carried clues of processes that might differ immensely from those that formed our native comets. That this interstellar wanderer could resemble a well-worn comet, almost too ordinary to be unique, stirred questions about the nature of planetary systems elsewhere. Was this activity commonplace, an almost standardized process of celestial migration? Or did Borisov emerge from a tumultuous environment, its dusty tail a testament to violent interactions, icy collisions, or stellar upheavals in its distant home? The notion that interstellar objects like Borisov could be commoditized, objects whose properties echo familiar patterns, raises profound questions about the universality of planetary processes. Could these visitors be products of a common planetary evolution pathway that arises independently in diverse star systems? The recognition that Borisov bore such similarities to comets from our solar system implies that, despite its foreign origins, the building blocks of life and the mechanics of celestial bodies might follow certain universal rules. Its brightness, its geothermal activity as it approached the Sun, and the subsequent planetary-level effects, altering the distribution of dust in the solar environment, are all striking reminders of the interconnectedness of cosmic phenomena. At a grander scale, these interstellar objects act like messengers, ferrying fragments of alien worlds across the void, reminding us that the universe is far more interconnected and dynamic than it appears. Each pass, each tale, each flicker of activity sparks existential wonder. Are these objects simply stray debris, or do they embody the restless spirit of countless worlds, each harboring unique secrets? As Borisov's journey continues to be studied, it becomes clear that every observation pushes us to ponder whether our solar system is a special enclave or just one of many amongst endless, swirling starry battalions, each potentially spawning its own interstellar travelers, their luminous trails writing stories that challenge our perception of loneliness in the cosmos. Discovery of 3I/Atlas, the Shrouded Wanderer's Secrets. The moment 3I/Atlas burst into the scope of astronomers' instruments was nothing short of awe-inspiring. This object was first detected in late 2019 by the Asteroid Terrestrial Impact Last Alert System, ATLAS, a network designed to scan the heavens for near-Earth objects. What made 3I/Atlas remarkable from its very first observations was how peculiar its brightness and trajectory appeared. An interloper moving at an incline no natural asteroid or comet from our solar system typically exhibit. Its incoming path suggested a foreign origin, a wanderer from beyond our cosmic neighborhood, silently piercing through the darkness with an energy that seemed almost otherworldly. As telescopes around the world aimed their lenses at this enigmatic traveler, puzzling details emerged. Unlike traditional comets, it lacked a visible tail or coma, signs of sublimating ice reacting to solar heat. Instead, it presented a subdued, featureless surface that hinted at a composition unlike anything commonly found nearby. Its trajectory was highly hyperbolic, indicating an escape from the gravitational grip of the Sun, fast and fleeting. It was as if the universe had whispered an ancient secret through this celestial shape, a fragment of a distant world wandering through interstellar space, only to be caught momentarily in our vantage point. Its discovery hinted at a universe teeming with objects we'd only begun to comprehend. The detection raised far-reaching questions about the nature of such objects. Was it a derelict piece of a shattered planet, ejected long ago, wandering somewhere in the interstellar void? Or perhaps an alien artifact, a fragment of some distant civilization that had somehow broken free from its star system? While the consensus favored the former, an interstellar asteroid, mysteries lingered around its surface characteristics and origin. The scenario of an object entering our solar system without prior warning invoked a profound realization. The cosmos is a vast, dynamic arena where planetary systems constantly exchange fragments, sometimes traveling millions of years before reaching us. The mystery of its composition, its dark surface, and its silent journey through space continues to challenge our understanding of planetary evolution far beyond the familiar confines of our solar neighborhood. As scientists endeavored to decode 3I/Atlas's secrets, they encountered the reality that the universe is full of silent, shadowy wanderers, objects that shift our perspective on what's possible. Its journey through our skies was brief but impactful. It burned with the faint glow of heat absorbed from the Sun, yet revealed nothing of the icy grandeur associated with traditional comets. Instead, the object's muted appearance seemed to bear witness to a composition of metals and rocky material shielded by layered regolith, hinting at a complex history shaped across cosmic spans. Each new piece of data seemed to deepen the enigma. How many such travelers remain hidden, advancing silent across the vastness, waiting for their moment to be observed and understood? In the grander scheme, The discovery of 3I/Atlas becomes a mirror reflecting deeper questions about our place in the universe. It's as if the universe, the grand, unfathomable entity, is teasing us to look beyond our little bubble of familiarity. What does this ancient wanderer tell us about planetary systems far beyond our reach? Could these objects harbor the biochemical traces or even signs of civilizations, traveling unseen for millennia? Is our understanding skewed by the limited scope of our sights, or does this mysterious interstellar visitor hint at a universe that is alive with motion, change, and silent communication at scales far beyond our comprehension? Unraveling the mysteries, scientific attempts and theories. The intrigue surrounding 3I/Atlas has prompted an array of scientific hypotheses and investigations aimed at deciphering its true nature. This object defies easy classification, exhibiting behaviors that challenge established notions of comets and asteroids. Its sudden appearance and rapid fade-in and fade-out patterns suggest a fragile, potentially volatile composition, prompting scientists to explore a variety of models. Some posit it could be an interstellar fragment, perhaps a relic of a distant star system, ejected long before our sun's birth. The unpredictability of its origin sparks awe, hinting at a universe brimming with cosmic travelers and remnants dancing across the vast stretches of interstellar space. Advanced telescopic observations have shown that 3I/Atlas has an exceedingly elongated shape, with a reflective surface that hints at complex surface textures or a layered exterior. The tiny, unpredictable outbursts, sudden jets of dust and gas, have baffled astronomers, as they suggest internal processes similar to volcanism or disintegration, yet with no obvious source. These phenomena evoke images of a celestial tether, fragile yet enduring enough to drift through the darkness, illuminated by distant stars. Scientists theorize that radiation pressure from the sun could be gently eroding its surface, causing sporadic activity, but the precise mechanisms remain elusive. Some proposals consider that 3I/Atlas might be composed of porous, loosely bound icy and rocky material, akin to a cosmic conglomerate, further complicating efforts to predict its behavior. The idea is that sublimation, the transition from solid to gas, might be occurring beneath its surface, releasing jets of debris that flicker like sparks in the void. This could explain the object's transient brightness and tail-like features, reminiscent of long-ago comets, but with a strange, unfamiliar composition. The fragility and accelerating disintegration evoke a sense of cosmic vulnerability, as this remnant gently dissolves into the abyss, leaving behind only fleeting shadows of its ancient history. The core mystery persists. What forces shaped 3I/Atlas's journey from a distant star system to our neighborhood? Researchers speculate it might be part of a larger population of interstellar objects, wandering through the galaxy, perhaps ejected during early planetary formations or cataclysmic stellar events. The possibility that it is a harbinger of worlds long gone ignites questions about the cosmos' inherent dynamism. As it slowly evaporates under the heat of our sun, witnessing its silent disintegration feels like standing outside the universe's grand, ongoing ballet of creation and destruction, a reminder that even the most enduring materials are ultimately consumed by the relentless march of time. In contemplating such fragile fragments, one asks how much of the universe's history remains hidden, waiting to be uncovered in its fiery glow or icy silence. Implications for future interstellar exploration and understanding. The discovery of 3I/Atlas sent ripples through the scientific community, shaking up how we perceive the universe's readiness to unveil its deepest secrets. Its unusual trajectory, combined with an enigmatic acceleration that defied typical comet or asteroid behavior, suggests that our exploration of interstellar objects, ISOs, is still in its infancy. These objects, hurtling through space at speeds that make our best spacecraft look sluggish, are not merely debris. They could fundamentally reshape our understanding of planetary systems and the distribution of matter across the galaxy. As we accumulate knowledge about 3I/Atlas and others like it, the potential for future interstellar missions grows exponentially. We are waking up to a universe far more dynamic and interconnected than previously thought, where the light and heat exchanged across interstellar distances might influence not just our planets, but entire star systems. The implications for future exploration extend beyond simple discovery. The composition, structure, and velocity of objects like 3I/Atlas open a corridor for understanding cosmic processes at a scale that's almost incomprehensible. Imagine spacecraft equipped with advanced spectrometers capable of analyzing surface materials, delving into whether certain organic molecules or minerals are common across the galaxy or uniquely tied to distant star systems. Such understanding might eventually guide us toward targeted missions. It's like having a cosmic map where every interstellar visitor is a clue. Plus, witnessing the effects of light and heat transfer during close passes gives us clues about their internal heat sources or even hints of artificial origins, which becomes wild to consider. This knowledge could inspire revolutionary propulsion systems, utilizing the very physics observed in these objects to craft faster, more efficient interstellar craft. Moreover, studying objects like 3I/Atlas enriches our perspective on planetary genesis and the potential for life beyond Earth. As these objects pass through different star system realms, they carry with them the chemical fingerprints of worlds far away, signatures that could reveal whether organic compounds or water ice are common ingredients in planetary formation. Future missions could involve intercepting and collecting samples from these objects, allowing us to analyze their makeup under controlled conditions. Such endeavors might tell us whether these interstellar visitors are merely cosmic dust or relics from civilizations lost to time, awakening profound questions about our place amid the stars. Their existence presses us to reconsider the notion that planetary systems are isolated islands. Perhaps they are interconnected hubs exchanging material and influence, like the heartbeat of a grand universe pulsating with shared origins. In the end, pondering the mysteries embodied by 3I/Atlas provokes the eternal question: are we truly alone in this vast, shimmering ocean of stars, or are we just early explorers glimpsing a universe teeming with interconnected worlds, each whispering stories through light, heat, and matter? Every new discovery nudges us closer to understanding whether our existence is a unique anomaly or part of a sprawling cosmic symphony that has been playing out across eons and light years. As we push toward greater understanding, the universe challenges us to reflect on our fragile yet indomitable quest to grasp the grand design, a question that no mission can answer, yet every exploration brings us closer to deciphering. As we step back from the enigma that is 3I/Atlas, what lingers is a profound sense of wonder about the tapestry of our universe. This mysterious interstellar visitor, with its strange trajectory, peculiar composition, and fleeting gaze into our cosmos, reminds us just how much remains beyond our reach, or perhaps just beyond our understanding. It's a fiery messenger, racing through the dark expanse, illuminating the fleeting boundary between the known and the unknown, heating our curiosity and sparking our imagination. Imagine the colossal forces at play, planetary shifts and cosmic currents, that sent this wanderer on its brief, spectacular journey through our solar system. Each piece of data we gather seems to whisper a cosmic story of distant stars and ancient worlds, hinting at secrets that could redefine our place in this infinite universe. We stand on the precipice of understanding, peering into the vastness with fascination, questioning whether we are truly alone or just a small star in an endless cosmic sea. If this stirs something in you, the awe of discovery, the humility of uncertainty, then stay tuned. There's more to uncover, more stories written among the stars, and a future full of revelations waiting to unfold. Together, we journey onward into the cosmic night, pondering not only what might be out there, but what it means for us right here, right now. Is our existence just a flickering light in the darkness, or the beginning of something far greater? That remains the deepest mystery of all.